Hi, I'm Papia. In this problem, we have to graph this polynomial x cubed minus 25x using first the leading coefficient test, then we have to find the real zeros, then we have to plot sufficient solution points, and then sketch a curve through those points. So let's start with the leading coefficient test. The function is x cubed minus 25x. So note that the leading coefficient is the coefficient attached to x cubed, which is 1. Well, it's not the value that we're interested in, it's the sign. Since the leading coefficient is 1, that means this is positive. Also, note that the degree of this polynomial is 3, which means this is an odd degree polynomial. So those two facts will help us determine what is happening to this function when x is approaching to negative infinity and x is approaching to positive infinity. Okay, so let's think about that. As x is approaching to negative infinity, that means x is taking large negative values, this particular term x cubed is dominating. So what happens if you plug in a large negative numbers for x? Well, it will be a negative cube with a positive coefficient in the front. So negative cube is negative, which means the curve falls to the left. Okay, now think of what is happening when x is approaching to positive infinity. So you're plugging in large positive values for x. Again, this leading term is the dominating term. So if you plug in a positive number, you get positive cube is positive, which means the curve rises to the right. So that's what we get about the curve of this function from the leading coefficient test. Okay, next we have to find the real zeros of this polynomial. And to do that, you just factor. So you take x cubed minus 25x and factor. Well, pull out a common factor x from both terms. You'll be left with x squared from the first term and negative 25 from the second term. Now notice that this is a difference of squares, x squared minus 5 squared. So you can factor it further. This is x minus 5 and x plus 5. So that tells you that the zeros are x equals 0 from the first factor, from the second factor, x equals 5, and from the third one, x equals negative 5. So what do we mean by these are the zeros? That means that the curve will cross x-axis at these points. So these are the x-intercepts. So the x-intercepts are 0, 0, 5, 0, and negative 5, 0. So we can plot those points also, and it will help us sketch the curve. Okay, we finished with part B. Let's move on to part C. Now, it's not a bad idea to find a few more points on the curve, on the graph of this given function, and then we can join all those points in the end to be able to graph it. So we already have some ideas what this curve will look like. See, we know that the graph of this function will cross x-axis at 0, 5, and negative 5. So we would like to know what is happening between those points. So let's find some points on the graph. Okay, so we know that x will, at x equals 0, the function will cross x-axis, and at x equals 5. So let's choose a point in between them, between 0 and 5. So let's choose, say, x equals 1. Okay, let's see what is happening. Well, you just take the x value, plug it in the function, and then see what the y value is. So if we plug it in the function, we get 1 cube minus 25 times 1, so that's 25. So we get a negative 24. Let's do the same thing between 0 and negative 5. So between 0 and negative 5, let's choose, say, negative 1. Okay, if you plug it in the function, we get negative 1 cube minus 25 times negative 1. Be careful with the negative signs. Okay, so we get a negative 1 and a positive 25. So this is a positive 24. Okay, let's use these points and the x-intercepts and see if we can sketch the graph. So that's part D. Okay, our x-intercepts are, let's write down the points. So we have 0, 0, 5, 0, negative 5, 0. Also, we got some solution points. They are 1, negative 24, and negative 1, positive 24. Okay, so let's start plotting. First, we have 0, 0. This is the origin. Okay, let's see. We have 5, 0. 1, 2, 3, 4, 5. So this is another x-intercept, and negative 5, 0. So this is negative 5. This is 5. Now we have 1, negative 24. So let's call this negative 5, negative 10, negative 15, negative 20, negative 25. So at 1, we are negative 24. So somewhere here, roughly. And on the other side, at negative 1, we get positive 24. So let's do the same thing here. This is positive 5, 10, 15, 20, 25. So at negative 1, we have positive 24. So somewhere here roughly. So those are the points. Now, why did I plot those 2 points exactly? I want to see, because I know that the curve will cross x-axis here and here again. I want to see which direction it will be. Will it be going under the x-axis or over the x-axis? And same between negative 5 and 0, right? Will the curve be over x-axis or under? We know that it will be a continuous curve, so we can just join these dots and we will have an idea of a rough sketch of this function. Okay, so we know now that between 0 and 5, the curve will go below x-axis. Okay, so we don't know how far it will go, so roughly. Now, what is happening to the right side of 5? Remember, in part A, we use the leading coefficient test, and we know that the graph will rise to the right. So it'll keep on going. Okay, now on the left of y-axis, between 0 and negative 5, see the curve is going over x-axis. So it'll join from between 0 and this point and go farther, and then it'll come down, cross the x-axis, and it'll keep on going, because we have seen that when x is approaching to negative infinity, the curve falls to the left. So roughly, this is the graph of this function x cubed minus 25x. Thank you.